So I fibbed with you last time. There are not 9 rules of replacement, there are 10. I'm sorry for my inability to count, but there are going to be a total of 10 rules of replacement to memorize, or to know for this time around, not to memorize, but to know here. So let's go over each of these here. So let's begin with transposition. Now transposition basically states, it's kind of easy to see, and if you did a truth table you could demonstrate this, that if you have a conditional statement, then an equivalent to that would be another conditional statement, but with the antecedent and the consequent flipped, and them both negated. Okay, so that's pretty much what is demonstrated here. If you had a case where it was something like, not P, horseshoe Q, and you wanted to use trans here, you would basically go, so using trans, you would go not Q, horseshoe, not P. Again, this is that thing where we have to, sort of as a formality, we have to put in the extra tilde here. And then we would go not Q again, because we don't want to just keep double negations there. We want to eliminate them. So we have P, and we used double negation on the previous line to get rid of these 2 tildes here. So transposition is pretty easy to understand. Basically, just unlike many of the other rules here, the main operator does not change, but the position of the letters does, and the negation of them changes as well. The other rule here, number 7, is material implication, or implication just for short. Implication is a little less intuitive, but it you can see how it sort of works. So, take for instance the original, so basically it states that if you have, for instance, beginning with a conditional statement, the equivalent to that would be a disjunctive statement where the previous antecedent is now negated. And again, with all these rules of replacement, it can work the other way. So you may start with the disjunction and then convert or replace, if you will, that disjunction with the conditional equivalent. So to take this as a kind of example here, you might have something like the following. If you wait around then the opportunity will pass you by. Okay. This statement is equivalent to basically saying either you do not wait around, or the opportunity will pass you by. It's the same basic statement here. Right, so you have two choices, essentially, what this conditional is stating. Either you sit around and you don't do, or you do not wait, or if you sit around and do nothing, then the opportunity will pass you by. Okay, so that's just basically how to, to put kind of flesh on the bones. That's how material implication works. The next rule of replacement is the material equivalence. Sometimes this rule is referred to as biconditional, just simply biconditional, or bicon. The way we will refer to it is we'll just use equivalence, equiv, as the shorthand for the rule. And we kind of talked about this, or it was at least mentioned, I believe, in the video on when we introduced biconditionals, that biconditionals are basically like, one way in which we can understand biconditionals is we can understand them like 2 conditional statements conjoined together. Okay, and as you can see on this first version here of using the rule of replacement, that's what exactly is being demonstrated. So to go back to that old example I referred to before, if you have a statement like JFK will increase its security if and only if LaGuardia does the same, another way of saying that particular claim, okay, is just to say JFK, if JFK increases its security, then LaGuardia will, and if LaGuardia increases its security, JFK will. Okay, that's demonstrated here on this very first line of which the rule is being used, but that works. Another way in which to use material equivalence is to convert it as the disjunction of two conjunctions with one of the conjuncts being negated. And this may not be as intuitive to see as the first way of doing this, but let me show you what's going on here. So again, using our JFK and LaGuardia example, doing this interpretation of the rule, we can say then that this statement up here is equivalent to JFK will increase its security and LaGuardia will increase its security, or JFK will not increase its security and LaGuardia will not increase its security. This interpretation of equivalence is basically a demonstration of what happens in a biconditional's truth table. Remember, a biconditional is only true when both sides of the biconditional have the same truth value. So as I think I mentioned in the previous video, in the biconditionals, the conjoined statements stand or fall together. So either both airports increase their security, or neither one of them increases their security. It has to be one or the other. It can't be one is increasing its security and the other isn't. It can't be that way because that would weaken a biconditional. And again, a biconditional is just a very strong conditional statement, because what's going on here, again, as demonstrated by this first interpretation of the rule, is that both letters are serving as sufficient and necessary conditions for one another. Okay, so that's just an explanation of why I think in many ways the second interpretation of equivalence is not as intuitive as the first. So, but this is, just think of, when the second interpretation here, just think of the truth tables of biconditionals. And that should show you how they essentially will work. Alright, the ninth rule here is exportation. And again, exportation, it might be just one where you just have to sort of memorize the form here, but what's going on here is that it basically states, if you have a statement where the conditional statement, I should say, where the antecedent is a conjunction, right, then you can interpret that, you can replace that conjunction with just two conditional statements. So again, to put the flesh on the bones here, you might say something like, Peter and Quincy will go to the movies only if, again, only if being interpreted as the word then, right? Only if, let's say, Rachel goes with them. Okay. In other words, another way of putting this is, in a longer sort of format, is if Peter goes to the movies, then if Quincy goes to the movies, then Rachel will go as well. Right, so again, it's just basically, the way to think about it is you have to have both of these conjuncts here. You have to have, in this case, both Peter going to the movies and Quincy going to the movies. And they both basically serve, if you will, as if you pulled them apart, if you will, they would serve as antecedents, individual antecedents of this larger conditional statement, because we have this big, on this one here we have this big conditional statement that the main one here is if and then, but then within, nestled within the consequent of the big conditional, we have another conditional statement, if and then, with Quincy and Rachel. So that's the basic way to think about exportation. And again, it can move the other way as well. You might need to, if you might have a case in a proof where you have this form where you have all the horseshoes, the side that has all the horseshoes, and you might need to put it into this format in order to make the conclusion correct, or to prove it correctly. The very final rule on the board here is, again, one of these sort of formality rules, like double negation and commutativity. And that rule is tautology. Okay, tautologies, again, are basically, if you did a truth table of a tautology, of a tautological statement, or two statements that are tautological, they would always be true. Okay, so that's what's being demonstrated here. Right, so either P is the equivalent to saying either P, or P is the equivalent of saying either, or saying both P and P. So, you know, for instance, you could say something like, if your option is either we win or we win, well, you really, this statement is basically, it might be a kind of what we would call maybe as a kind of a joke, a meaningful tautology, because what this is saying is that you have no choice but to win. This is the equal of saying as we will win. Okay, and the same thing can be demonstrated with tautological statements that involve a conjunction. So these are now in full all 10 of the rules of replacement that you'll need to know to complete our understanding of natural deduction.